Every grain of white rice in your kitchen started out looking nothing like this. Before it gets there, a mill strips it down layer by layer, pulls out anything broken, burns part of what comes off, and sorts millions of individual grains, one at a time. And almost none of what disappears along the way is actually thrown away. Across the world, hundreds of millions of tons of paddy pass through rice mills every year. For every 3 tons that go in, roughly 2 tons may leave as milled rice. The rest comes out looking like something else. Where it goes is most of this story, but the grain has to survive a few things. First, rice is one of the world's most important staple foods, feeding more than half the world's population, and almost none of them have ever held it in the form it left the field. This story starts about 9,000 years ago in the marshes along the Yangtze River in southern China, where a wild grass was coaxed season after season into a grain that wouldn't scatter its seed before it could be harvested. That ancient selection changed the plant forever and eventually helped create the crop that feeds billions of people today. But the history stops here, because the paddy is already arriving. Trucks back up to a receiving pit stacked 3 stories above the factory floor, and the grain pours down in a golden tan river. Dry, hard line. Except it isn't dry yet. Not really. Rice comes off the field carrying a quarter of its weight in water, and if wet paddy sits too long before drying, that moisture feeds its own heat, enough to discolor and deteriorate the grain before milling even begins. So air forced through it for hours, until the moisture drops from around 25% to 14%. Too fast, and the kernel fissures invisibly, waiting to shatter the moment a roller touches it later. Too slow, and mold gets there first. That single number, 14%, is the difference between a batch that mills cleanly and one that can suffer serious losses. A bucket elevator hauls the dried grain upward, load after load, into the first machine in the chain, a cleaning sieve shaking hard enough to blur, throwing off chaff and dust, while out of the grain stream entirely. Here's the first surprise. Stoning deck tilts and vibrates beneath it. Walking actual stones sideways, touches the rice first, isn't built to clean the rice. It's built to protect the machine after it. Because a single pebble, riding along with the grain, can jam or crack a set of steel rollers and bring an entire milling line to a stop. Before any shift starts, an operator checks a sample from the incoming stream, measuring moisture, looking for impurities, and judging the grain itself. A reading even a few points too wet is enough to hold an entire truckload at the gate, no matter how far it has already traveled. Past the destoner, the rice hits the husker. 2 rubber rollers spinning at slightly different speeds, close enough to grip the grain and tear the husk clean off without the grain. And what comes out the other side is brown rice, still washing what's inside. The process repeats continuously. Grain, bran, the reddish-brown layer that gives it color, weight, and nearly all its texture. For the first time, the grain looks like something people would recognize as rice. But brown rice still isn't what most people buy, and the color that finally gets it there is still several machines away. Not every grain gets husked clean on the first pass. A separator downstream shakes and bounces the mix on an oscillating deck, sorting more than how each one bounces on the moving surface. The remaining unhusked rice from grain still wearing its husk, by nothing grains, are sent back through the husker to try again. Not every mill gets the moisture calibration right, and rice remembers that mistake violently. When drying goes wrong, the damage isn't always visible right away. A kernel can look perfectly normal from the outside, while microscopic cracks have already formed inside it. Cracks that only show up later, when a roller touches the grain, and it shatters, instead of husking clean. The husk is the first thing in this process that looks like waste. It isn't. It's close to a fifth of the grain's original weight, and at mills equipped for it, the husk goes straight into a boiler, becoming the fuel used to dry the next batch of rice. But the husk isn't even the most valuable thing this mill is about to remove. Brown rice moves on to the whitener, a tall steel cylinder lined with abrasive rollers, spinning hard enough to sand the bran layer straight off the grain. It comes off as a fine reddish-brown dust. The bran fraction that gives brown rice much of its cuts left underneath is pale, faintly, and the friction cracks grain that survived everything before it. Too soft, translucent, still dull. The operator doesn't trust the panel setting alone. Too hard, and the bran stays on, and the whole batch grades down, so the whitener's output gets checked against the grain itself. Whiteness, temperature, breakage. Because a setting that looks right on the display can still be wrong for what's coming through. From there, the rice enters a polisher, where a fine mist and a slower cylinder buff the grain to the glossy, almost translucent white that ends up on a dinner plate. This is where the rice finally gets the look most people actually recognize. Not in the field, not in the husk, but in the last few minutes before it's what the rice is worth. Some rice never reaches this stage looking like this, certain weighted by size. Every layer this mill removes doesn't just change how the rice looks. It changes steamed and soaked before milling begins, a process that can drive some nutrients from the outer layers into the kernel and also rollers ahead. A length grader separates on the grain, improving how much of it survives whole through whole kernels from broken ones by size, sending each down a different stream. This machine isn't just deciding which grain survives whole, it's deciding which grain gets sold as premium rice at all. A broken kernel isn't discarded. It becomes rice flour, brewing ingredients, or animal feed, but it can sell for substantially less than whole grain rice, depending on grade and market. The factory hasn't created garbage, it's created a different grade of the same grain. A mill's whole goal at this stage is to maximize how much rice survives whole while keeping breakage under control. An older or poorly adjusted mill can produce dramatically more broken rice than a well-tuned one, not because the grain was bad, but because a roller was worn, a moisture reading was off by a single percentage point, or the grain, a camera watching every kernel fall, a burst sat too long between steps. An optical sorter is the last gate before packaging, narrow channel as an agricultural product gets. From there, compressed air kicking out anything discolored or chalky in a fraction of a second. What survives is as close to identical, kernel to kernel, it reaches the packaging line. Rotary scale heads dropping exact weights into bags, each one heat sealed and dropped onto a pallet, bound to cross a border before anyone opens it. India is the world's largest rice exporter, accounting for a major share of all the rice that crosses any border on the planet. None of that damage shows up on the price tag you actually pay for it, which is where the money in rice gets strange. A farmer in the Philippines was paid, on average, about 30 cents a kilogram for unmilled paddy last year, a price that had fallen nearly a quarter in 12 months. A mill processing that grain for a fee typically charges $15 to $40 a ton, barely enough to cover electricity, wear, and breakage risk. Then grading separates that rice into different grades of value. Packaging gives it a name, and shipping and retail each add another layer on top. Multiply that gap by the more than 500 million tons of milled rice the world's mills turn out each year, and the difference stops looking like a rounding error. By the time a bag reaches a supermarket shelf, its price bears little resemblance to what was paid at the farm gate, and the farmer who grew it was only the first stop in a chain that can stretch across continents. When paddy prices swing, some mills answer a bad season by cutting corners, running the line faster, skipping a rinse, letting the broken percentage creep upward to protect the margin. The operator who mowed doesn't do that, slows the line down instead, and holds the same standard, whether prices are up or down. And when the process fails, it fails at scale. A significant share of milled rice leaves the line as broken kernels. The exact equipment is adjusted, but every extra percentage point of breakage means a real loss in value. That's not one bad harvest. That's one of the central problems rice milling has spent decades trying to control. In Japanese, the word for cooked rice, gohan, is also the everyday word for a meal, any meal, whatever's actually on the plate. Rice wasn't just eaten, it was assumed. That assumption, rice is measured in tons and cents per kilogram. There was a time it was measured in something far more personal, wealth itself. In feudal Japan, a lord's entire wealth was counted not in gold, but in koku, a traditional unit of rice, considered enough to feed one person for a year. Samurai were paid their rank in koku. Entire domains were ranked by how many koku of rice their fields could yield. For a few centuries, rice wasn't traded for money. Rice was the money. By the 1640s, merchants in Osaka were stacking entire warehouse districts with rice, collected as tax from those same feudal domains. Trading claims on it so heavily that by the 1730s, they were running something close to a futures market, buying and selling rice that hadn't been harvested yet, off the price of rice that had. Rice had become sophisticated enough, as a commodity, to support organized trading in contracts for future delivery. That history is exactly what makes the modern economics land strangely. The grain that once measured a person's entire wealth is now just one link in a global supply chain, and the farmer is only the first one. In the grading room, an operator runs one more check before any batch is cleared. Moisture, whiteness, broken percentage, measured against a standard some mills refuse to lower, even in the years paddy prices crash, and everyone else is cutting corners to survive. Here's the part almost no one expects. The husk and bran the machines strip away aren't just leftovers. For some mills, they're a real second revenue stream. Rice bran oil gets pressed out and sold into cooking oil and cosmetics, prized for the same fine texture that made it hard to separate from the grain in the first place. Rice husk, once burned, leaves behind an ash so rich in silica that it gets processed further into materials used in everything from concrete and rubber to higher purity industrial applications. None of it comes free of risk. Rice husk is still organic biomass, and when it turns to fine airborne dust, that dust is combustible enough to ignite, which is why mills run ventilation, dust collection, and grounding systems to manage the hazard. The machines that made rice cheap enough to feed billions are also machines that have to be watched every hour they run. Remember the missing third from the beginning of this. It didn't disappear. It became fuel for the dryers. It became bran oil, rice flour, brewing ingredients, and animal feed. It became ash rich enough in silica for concrete and tires. Sometimes, it simply became a cheaper grade of the same rice. Every bag of white rice on a shelf is what's left after all of that was deliberately separated. Husk, bran, broken kernels, dust, and everything the factory decided the final grain didn't need. The white grain isn't the rice as it came from the field, it's the part that survived. Somewhere downstream, an operator still decides every single day whether a batch is good enough to carry the mill's standard or whether it goes back through the rollers again. Somewhere on Earth, right now, another load is already entering the same machines. Nothing about it will disappear. It will just change what it's called.